All right, this video is going to show you how to graph parametric equations on the calculator. Um, Obviously, we can also use algebraic equations and solve for time and maximum height. And I'll show you guys both ways, but I just prefer the calculator way just because you already have it in the calculator and you can just use trace to help you find everything. Just a couple of reminders that the horizontal component is v sub 0 cosine of theta times t. So we have velocity, cosine which represents the x component, and then t representing time. You have two equations depending on if your problem is in terms of feet or in meters. In these couple examples, we are going to be using feet. So we are going to use the negative 16t squared plus v sub 0 sine theta times t plus h sub 0. Negative 16t squared represents your gravitational constant after we did the negative 1/2 g times c squared. Velocity, sine represents your y component, and then h sub 0 represents your initial height. Looking at number 1, we have Sharon releasing a baseball 4 feet above the ground with an initial velocity of 66 feet per second at an angle of 5% with the horizontal. If I were to make a parametric equation for this, then I know I would have 66 cosine of 5t, and then negative 16t squared plus 66 sine 5 of t plus 4. Part B says, at what time will the baseball be at its maximum height? So for this one would actually be using the axis of symmetry formula, just because whenever we do start graphing this on the 84, we can't really find what the maximum height is precisely, but we could do it algebraically using negative b over 2a. Aka my axis of symmetry formula. This is going to help us a little bit because later on it does tell us give the horizontal distance and the vertical height. So once we get this x value, we are going to substitute in whatever this is into the y to get your maximum height. Or if you were to plug this into the calculator, where we have 66 sine of 5 divided by 32, that's going to give us 0.179. So that's going to be my time. At 0.179, that's going to give us our maximum height. What's our maximum height? We don't know what that is. So, like I said, you could substitute in 0.179 into this equation to get your horizontal distance, and this equation to get your vertical distance. But I'm not going to do that. I'm actually going to put everything into the calculator and look at the graph. You do want to make sure that your equation is in parametric mode and it is in degree. Love getting an ad for Moe's. LOL. Our equations, 66 cosine of 5 times t, and then a negative 16t squared plus 66 sine 5 of t plus 4. Now, if we were to graph it, it's going to look something like this, which is not pretty because obviously we need to change our window. So I'm going to change this to 0, and then maybe a maximum of 100, 0 for my y-min, and then a maximum of 100, and see how that looks like. It might not work, and if it doesn't, then we can just change the window again. Obviously, it does work, but notice how it looks kind of wonky. So I'm going to change my window again to have a maximum of maybe 50 for X and then 10 for Y. At this point, it's just a guessing game of what your maximum is and what your minimum so that you could see the parabola. So right here, I could see the parabola very nicely. And what I'm going to do is trace. And our time we set earlier was 0.179. 0.179. That's going to give us our maximum height and the horizontal position. So this tells me that at 0.179 seconds, the ball reaches its maximum height of 4.5 feet vertically at 11.76 horizontally. And obviously, once again, you could plug this into here and here to verify. Your answers might be a little bit off, but that's okay. As long as they're within the region, then I'm fine with whatever your thing is. Number 2, Spencer practices kicking field goals 120 feet from a goalpost with a crossbar 10 feet high. He kicks the ball from the ground with an initial velocity of 70 feet per second at a 45-degree angle with the horizontal. The first thing that I'm going to do is write the parametric equation to represent the kick that Spencer is making. So I have initial velocity of 70, cosine of 45, t. And then we're still on feet, so negative 16t squared plus 70 sine of 45t, and then plus 0. And notice how this is just the parametric equation for the kick. We also need to take into account of the goalposts. That is 120 feet away with a crossbar of 10 feet high. So I'm going to have X be 120, which basically represents that it's 120 feet away. And then I'm going to have Y be 10. And then T over T max, whatever my T max is. And there is a reason why I have T over T max. And I'll explain whenever we type this into the calculator. So what I'm going to do now is put this into the calculator. So I have x1, y1 already done, which is the ball. And then I have 120. If I were to change my window, maybe I'll do 100. There and 100 here. Let's see where that is. Okay. Maybe not 100, but maybe 50 for my Y max. And then obviously I need to be somewhere that's greater than 120 since that's where my goalpost is. So I'm going to do 50 for my Y max and 150 for my X max. Let's see where that is. Okay. There is my graphs. Notice how here in red that if I were to type in a t of 2 pi, that it is at 9.999 because the goalpost is 10 feet high. Had I not had that, and I just had 10, it's just a dot. And if I had 10t, then notice how it goes all the way up, and that doesn't take into account of how my crossbar is only 10 feet high. So that's why you want t over t max. In this case, my t max was 2 pi. Oops. Okay, so will Spencer make the field goal if the kick goes true? As you can see, the blue, he will make the goal. And if he does, by at what time and by how much? So at what time, we just need to figure out where Spencer's position is, the ball is, in terms of 120. I'm going to trace up. Let's do 2.5. 2.5 gives us 123, so let's see 2.3. Nope, 2.4. At this point, it's just a guessing game of trying to figure out where your ball is in terms of 120. And honestly, it doesn't have to be exact, so I'm just going to say 2.44 and call it a day. So we could see that it's going to be around 2.44 seconds. Now, if you want a precise answer, then this is where I can substitute in 120 as my x value, and then see where your time is. So that would be saying 120 divided by 70 cosine of 45. That's going to give me t being 2.424366, which is close enough from what our graph was. Part C says if he does make the goal, at what time and by how much. Time is 2.42. And then by how much? Well, looking at this, we could see that our vertical position is at 25.51. So 25.51 minus 10 feet, which is the crossbar position of ball. So he makes it by 15.51 feet. Part D says, at what time will the football be on the ground? Well, that's when you set y is equal to 0, and then you can solve it algebraically by factoring out a t. Or you could look at the graph and see where is the ball at 0. And I'm going to change my window again because I can't really see it. Maybe 170. So I can see that. Then what I'm going to do is look at, so let's say 3 seconds. So it's not 3. Oops. It's not 3.1. 3.05, 3.6, 3.8, 3.09 is going to be as close as it gets. So this is going to tell me that at 3.9 seconds or so, the ball is going to hit the ground, and then where is it going to be at? Well, that's going to be 152 feet away from wherever Spencer was at.